Which Alan has a new process now from our last episode. He's starting a new company to get polar bears trained to push down all these wind farms at the end of life.
Hey,
so
it'd save you about $1 million a
stay
turbine.
tuned for that.
But how much does a polar bear cost? I wouldn't have thought that would be cheap.
Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. On today's episode, we're going to talk about a recent wind farm repowering. We'll talk about a new bond push after some pretty crazy photos of discarded turbines up in New York. We'll talk about plant-based epoxies, piping hydrogen, the cost of green hydrogen in the future, shipping hydrogen, and we'll talk about some new technology helping to shut down turbines when it detects birds. So before we get going, be sure to subscribe to Uptime Tech News, which you'll find in the show notes of this podcast. Again, that's our weekly update and podcast newsletter. It's great to stay in touch with everything on the current edge of the news cycle. And be sure to subscribe to Rosemary's YouTube channel, which you'll find in the show notes as well. She puts out new content each week. So if you're, a wind energy and renewable energy junkie, you'll definitely find a ton of value in her content. So definitely subscribe when you get a chance. So let's get started here today. Alan, there's a wind farm run by EDP Renewables, and they've successfully repowered this. This is the Blue Canyon 2 wind farm. But what strikes me as a little strange is they repowered from 1.8 megawatt turbines to, drumroll please, 2 megawatt turbines. So 13%. Does that strike you as odd? That strikes me as strange. I feel like you had 1.8, you're real excited to go to 6.5 or something.
Yeah, but you can't reuse any of the components. And I think the benefit of repowering, and what's going to see a lot of because of the age of turbines is starting to get there in the United States, is you have a tower, you have a pad, you've got the transmission lines, you've got the transformers already there. So how much can you increase the generator by to get that extra 10% of power, which is 10% more cash flow? And the economics are really interesting on that. I've just been remotely involved in a couple of these things, and it looks like you're going to see a lot more repowering in the United States, and most because 90% of the turbines already there. And if it's in still good working condition, then why do you want to knock it all down and start over again? I think that's a pretty good argument. Why would you want to stop what's already working? It'd be like every 15 years knocking down the natural gas power plant and starting over again. I think they're kind of using that same model, like it's pretty much up and running. We just need to maintain it. And if we can squeak out a couple more percentage points of energy production, then fantastic. And I think that's good, Rosemary. Do you see more repowering happening in the next couple of years?
Yeah, I think so. I think it's kind of two opposite kind of trends that we see on aging wind farms. So, and it will depend on the site specifics and how old the wind turbines are and how far technology has come since then. So you'll see where possible, you repower, you get a little bit more power from the same turbine, extend the life of the turbine. So that's a good cheap way to get more electricity, more energy from your wind farm. But on the other hand, you do see also some old wind farms that are, using aging technologies and in particular really small turbines compared to what's available now. Right. Some of those old wind farms, like the first ones, are always on the very best sites, right? So I think we see starting to happen maybe now in Australia. Some wind farms are not at the end of their life, but they want to decommission them so that they can make better use of that really excellent wind resource. So it's kind of, in a sense, like two opposite things. One is, extending the lifetime of an existing wind farm, and the other one is getting rid of it early. And they don't just throw the turbines in the bin; they'll put them somewhere else. There's a market for secondhand wind turbines. But yeah, it just really depends on what the potential of the site is and how good the turbine was to start with.
But so they replaced the nacelles, the blades, and the top tower section. I mean, that sounds like a lot. I I mean, especially with components getting more efficient, and I mean, you'd assume nacelles have now way less given the same output, right, than they did before. It still strikes me as strange that such a small margin of increase would be present here. I mean, does that strike you as strange, Rosemary, or not so much?
Well, I think it varies from project to project, but presumably they're replacing the generator if they're going from 1.8 to 2. I mean, they would have to, because you can't just like get more out of a smaller generator. So I guess that they have to replace the nacelle because, it's not the correct one to fit the new generator in. Otherwise, I wouldn't think that a nacelle would be something that you would need to replace because they're pretty lightly loaded. And then with the blades, sometimes they replace them. Sometimes they just extend the tip. And sometimes they might leave the blades and just do a lifetime extension, which basically involves recalculating its lifetime, because when the wind turbine blade is designed, they will, calculate its basically how many bends it has in its lifetime to calculate the fatigue loading. And 20 years ago, the manufacturers didn't have as good an understanding about how their materials behave. So they were quite conservative with their, the values that they would put into their calculations. And now we know more. Maybe that the wind turbine wasn't used, that the loads that they assumed for the site didn't eventuate. So you can rerun those calculations, and very often you're getting, extra years of lifetime without having to do anything, just because they realize now that they really overbuilt it at the start. So it will just depend on whether or not those factors are relevant for that particular site as to whether or not they need to actually change things.
So it sounds like then that they ran all the numbers and they're like, yeah, like we can keep foundation, all the infrastructure, like this is the best we can do. Is that what it sounds like, Alan?
It does, and I think it's not a bad move. It makes sense to me, and I think on the blade side, as Rosemary has pointed out, there's been the projects I've been around. What they're doing is actually improving the aerodynamics of the blades at times. Blade extension is one of those, but cleaning up the leading edge, fixing all the little structural defects that may be in there today, adding vortex generators. Get a couple of percentage points more power out of the existing blades is really interesting because we don't always see that. But a couple of percentage points of more energy production is actually a lot of cash. And so it makes sense because your return on investment time can be a year or two. And if you're talking about a 20-year time span in which you're going to be generating revenue, then if you earn it back in a year or two, that makes total sense to do. And I think that's what's happening.
So let's switch to end of life. There's an interesting photo that has been passed around, especially LinkedIn a bunch, which is from an article from Observer today. And it was from Andrew Goodell, who's a Republican for the New York State Assembly. And it's him. I guess he was driving along the highway, saw a gigantic heap of discarded turbine blades, and took a photo of it in front of it. And this has really just stirred up the discussion about bonds and end of life bonds to decommission wind and solar projects at the end of their useful lives. Alan, this is probably not that far from you up there in the Northeast.
No, it's not. Yeah.
But so I expect you to go home and get you a nice new wind turbine to do some testing on, or a turbine blade. But I mean, it kind of surprises me that there's still heaps like this, given all the bad press last year. You kind of felt like, oh, everything's kind of being dealt with, but maybe it's not, or maybe this is on the road to recycling. I don't know. What's your take here?
That's a good question, because when I saw that article, the first thought is, well, that's just a holding place, right? And those blades are going to be recycled, and they're just there temporarily. But then nothing in the article indicates they're going to be recycled, which is weird because we've had Veolia on the podcast, which they recycle wind turbine blades, especially they're reusing them in cement plants, and there is a cement plant not very far from where these wind turbines are currently stored, where that energy could be used. And so it is weird. And I know on LinkedIn, the same thing, and Rosemary's probably seen this, there's been a lot of discussions about recycling of wind turbine blades lately. And there's see these pictures of big piles of wind turbine blades. And someone brings up, well, why isn't someone recycling these things? And the answer is they already are. I mean, we already have the technology to do it. I'm not sure why nobody realizes it, because you can You can Google it, and it's not hard to find, but maybe it doesn't stand out, or maybe it's country specific. Maybe that's the other thing too. Is it seems like the Midwest in the United States is already working on recycling, but maybe not so much in the Northeast where I am. It's just very odd. But and Rosemary, I think the bigger question is this bond issue is, are they going to force the owners, operators to basically put a bunch of cash into a bond to take down the turbines? Because it doesn't sound like that was done in this particular case. And they want to start changing the rules, which is not a good time to do that once the development's already happened. But if they go back and start saying, hey, you're going to have to issue a bond to take down these turbines, doesn't that really impact the profitability of the wind turbine sites?
Well, there's plenty of places in the world that require something like this. And in fact, we were talking on a recent podcast, we talked about this new decommissioning method that, the process where it was like chopping down a tree to get the pulling the towers down.
Oh,
and
yeah, right.
The whole point of them developing this new process was that it was cheaper, and that meant that they had to set aside less for the decommissioning because they had a cheaper process. So,
which Alan has a new process now from our last episode. He's starting a new company to get polar bears trained to push down all these wind farms at the end of life.
Hey,
so
it'd save you about $1 million a
stay
turbine.
tuned for that.
but how much does a polar bear cost? I wouldn't have thought that would be cheap.
Well,
Breeding them.
The way we've increased chicken size here in the U.S., I mean, I'm sure we could get polar bears into the 4 or 5 metric ton range. Just a couple years of anyway.
Yeah, I mean, this is one of those issues of wind turbine blade recycling. It's the wind turbine blades going to landfill. It's one of those things that comes up again and again and again, and it's just, it's a bit weird for several reasons. I mean, first of all, because wind turbine blades are 5% of all of the things that are made out of composite materials and face the exact same recyclability issues. It's also the same as there's any number of products that are technically recyclable but aren't recycled, like plastic bottles and even glass bottles are not recycled nearly as much as you might assume because they're, recyclable. But if it's cheaper to use virgin materials than it is to use the recycled materials, then that's what people are going to do. And it's why you see, aluminium is highly recycled and, plastic bottles less so. It's an economic question of either the technology needs to get better that, recycling something, all those processes that you do to take a blade and recycle it into a usable material has to be so cheap that it can compete against virgin material, or you need to force people to do it for some reason. And we've seen it a lot in plastic bottles. You see heaps of consumer pressure on the manufacturers. And now you do see bottles that are made out of recycled plastic, not recyclable plastic, but actually recycled. And it's not because it's economical to do it like that, except for that customers won't buy it if it's not. And so with the wind turbine blade issue, another thing is that it's not that weird to require a developer to set aside money for decommissioning. I mean, you do it with nuclear power and you do it with many wind and solar farms around the world. So I've got no problem with them doing it for wind as well. And then the other thing is you got to compare it against what are wind turbines replacing, and then they're replacing, coal power plants that involve many times the amount of mass of, coal being dug up. And I mean, it doesn't just disappear when you burn it, right? It goes into the atmosphere and it goes into ash, which is full of toxic chemicals and much more massive than the amount of waste that a wind turbine makes for the same amount of energy produced. So it's just, like I said, I just can't understand why people keep on raising this issue. But it's just that thing where if you've got a green technology, it has to be 100% perfect. Otherwise, everyone, is outraged about it. It's not enough that it's better on every single metric than the incumbent technology. It has to be literally perfect before people will stop carrying on. So I'm a bit bemused, but kind of used to feeling that way by now.
Well, sticking with the topic of recyclability, there is the Composites Core program from the U.S. Department of Energy, and NREL researchers and some others are doing work in defining carbon fiber composites with bio-based epoxies. Obviously, we had green boats on the program just a few episodes ago. and they've been at the forefront of using bio-based epoxies and other materials in their boats and in their more mass market products, including their nacelle that they did last year. Alan, you're our resident materials expert along with Rosemary, but what do you see here with bio-based epoxies? Are they going to really be able to work? And is there sort of an alternative to carbon fiber in our future? I mean, what is some of this research leading us to?
Well, I think the goal is to really break down the epoxy system and to get all the carbon fiber and fiberglass back out of the blade and try to reuse it in some other industry, probably automotive or something similar to that. The interesting piece of this is that the effort that has gone into making this plant-based epoxy, I haven't seen a lot of structural data on it, which is odd, because at the end of the day, the reason you're using epoxy is because it's so dang good structurally. and there's what clicks in the back of my head is like, oh, let's just say there is this plant-based epoxy, and just say it works great in the laboratory. We don't really know how it's going to work for like leading edge erosion, hot, cold, wet, all those things that composites engineers do all the time. And you wonder why they're always in the lab all the time pulling samples apart, is because they're trying to make sure that the epoxy system and the fiber doesn't break down over time. And you just got to feel really uncomfortable. It's like when we made the switch from like wood airplanes to aluminum airplanes, like, oh, there's a little transition there. We need to figure it out. We went from aluminum airplanes to carbon fiber airplanes. It's like, there was like a 10-year period where or 20-year period. We were trying to figure it out to make sure that we didn't kill anybody. And yet we got this really weird plant-based epoxy thing going on, which is great. Maybe it works great. But you would like to see some published numbers on it. You'd like to see some data on it. And Rosemary, wouldn't you be just saying, it sounds awesome, but until someone gives me the data set, it doesn't matter.
Yeah, there were a few claims in the article that I read that need some evidence to back them up before I can really believe them, because they say that that you can separate, degrade the resin at room temperature.
Room temperature, right.
That's great, but obviously you've got some sort of tension between making a material that's durable and one that's easily recyclable. So,
right.
If it's so easy to separate the fiber from the resin in, when you want to recycle it, how confident are we that it's going to be durable in operating conditions?
Right.
So, like normally when they're trying to make recyclable blades using the thermoset, the idea is that you can heat them very high and melt the resin out again, which you obviously can't do with a thermoset. But, at least then well, if I need to heat this to 80 degrees, my blade will never see that in its operational lifetime.
Except for lightning.
Exactly. Yeah, right. Okay. I guess that is, lightning just complicates anything that you want to do in a wind turbine blade these days. That's
seems like it,
my general take. Yeah. And then the other claim in the article was that they said that they can maintain the fiber quality over at least 3 material lives, so they can recycle it without any detriment to properties. But one, that's very rarely the case that you would get something exactly as good as it started. And 2, if it has got a limit to how many times you can reuse it, then to me that says that it's degrading a little bit each time.
Sure.
So, it sounds really cool, and I'm not seeing any red flags, but I would like to see the evidence behind some of these really cool features that the product has, because obviously this isn't the only research team that's been trying to do this. We've been trying for decades to make better, more recyclable composite materials.
Well, moving on, Siemens Gamesa is considering replacing power cables offshore with pipes, and they're trying to use a thermoplastic composite to jointly transfer not only hydrogen, but I don't know, Alan, is this power as well? I'm not really clear on what they're trying to accomplish here.
It seems like they're trying to create hydrogen on site and then pump it back to shore. And I know Rosemary is, super into hydrogen and is the fuel of the future, but it does seem a little. I understand the process of that, right? So you got a wind turbine, makes electricity. You break down water, you get hydrogen and oxygen. You take the hydrogen, you shove it down a pipe and out comes the other end. It's not complicated, right? I mean, you can send electricity down wires, you send hydrogen down pipes. Okay, sure, it's basically the same difference. However, there's a lot of energy lost in that mix. And Rosemary, you want to describe how much energy you're losing when you make that transition to hydrogen gas or hydrogen liquid?
Well, yeah, so I'm assuming that they're going to be transporting hydrogen gas through the pipes. I guess it could be liquid, but that would really, really surprise me. If you want to liquefy hydrogen, I know it takes a third of the energy in the hydrogen to liquefy it, and you never get that back. And yeah, I think with this idea of offshore hydrogen, it is an interesting concept because there are some efficiencies to be gained by doing it that way. If you don't need to convert the rotational energy to electrical energy and then transform it and, put it along a lossy cable, and subsea cables are expensive and they have problems. So I can see that there are a lot of problems that you solve by putting the electrolyzer in the wind turbine, get some efficiency and solve some, bypass some engineering problems. But you also are going to create as many as you're going to solve, I believe. I'm glad that we're trying this. I think it should be tried. And as much as I'm pessimistic about the hydrogen economy and that I don't think hydrogen is going to replace electricity and everything that people say it will, 100% for sure we're going to need a lot more hydrogen than we have now, green hydrogen than we have now, even if it's only to replace what we already use dirty hydrogen for. So I'm glad to see someone try this project, but I suspect that we're going to find out that, putting all this complicated equipment offshore is really causes painful projects, because in general, the rule of thumb for offshore is that anything at all that can be done onshore should be done onshore because it's so much cheaper. It's really expensive. If you're adding any complicated equipment that needs maintenance or might malfunction, just costs so much, and especially so much in downtime to get crews out there. So glad that we're trying it, but I suspect that we won't see this be the widespread solution.
So to be clear, is this saying that wind turbines, like some of these wind turbines, don't produce electricity? I mean, they don't produce electricity in the sense that they're not pumping electricity back, but they're producing electricity, converting it to hydrogen, and then shipping the hydrogen back. That's how this works. So instead of piping, cabling the electricity back, they're going to convert it and then convert it back. That's the solution here? I
don't know if they need to convert it back. So I don't think it's a normal, you have to look up this company, I think they're called Hydro, that they have an idea to, and Siemens probably have their own. You don't just take a normal wind turbine and kind of, connect the power cord into an electrolyzer. You'll bypass a few electrical components, right. And Alan probably can give a better idea about what those are. You can bypass some components, get rid of some conversion losses that you have in a normal wind turbine. So you start with a little bit more. Maybe you're also not so limited in the, you can put a bigger electrolyzer than you might be economic to put in terms of a generator. So maybe It was only economic to put a 2 megawatt generator, but you can put a 3 or 4 megawatt electrolyzer. And so you can, use you can get more energy out of a wind turbine than you would otherwise. And then you would transport the hydrogen. You could convert that back to electricity at the other end, but that, you're going to end up with a lot less electricity from the conversion losses there. The more sensible thing would be to do that when you needed hydrogen. So, you'll either store it or use it for, I don't know, whatever thing you think you're going to use hydrogen for in the future.
And has this been something that's been done before? I mean, are there any offshore or onshore turbines producing hydrogen actively now, or is this completely novel?
I don't think that anybody's actually installed one yet. There's definitely several projects in development.
Yeah, I've seen the same thing. I think there's some, I want to say off the coast of Germany right now. I think there's a couple small efforts, and good. We can criticize sort of whether it's going to be worth it or not. That's an economic argument, right? I think the technology-wise, they need to figure it out. And I'm glad somebody's trying it and trying to see how efficient it is, and can they scale it up, and are there some savings to be had? And until you like Rosemary and I talk about all the time. It's one thing to do it in the laboratory. It's another thing to do it in real life, and to get some real numbers are important here, because you're not going to know until you, in this case, build it and try it. Good. Let's see what it does.
Well, speaking of hydrogen, new report that shipping liquid hydrogen is about 5 times as expensive per unit of energy as liquid and natural gas. Alan, I mean, is demand for liquid natural gas, I mean, is it going to continue to be significant? I know people hate their electric ranges, so it's going to continue to have its use. But what's important about this article with comparing these two gases?
It's just the economics of it don't make sense, right? And there is a lot of shipping of liquefied natural gas, LNG, around the world at the moment. It wasn't but a couple of weeks ago where there were ships headed to Europe to support Germany's energy crisis and tried to help out there. And then I think China was doing the similar thing. There were LNG ships rolling around trying to maximize price, right? Go where the demand is high, and you put it on a ship and you send it over. The hydrogen thing is, because its energy density is not there, it really hurts you, because it costs you the same amount to transport it, but it's just a lot less energy contained inside of it. So it doesn't make sense, right? I mean, eventually it gets down to the economics. Follow the money. Good example. Follow the money. And if there isn't any money in it, people won't do it. And the shipping, it doesn't make any sense. And just like we're talking about making hydrogen local, I think that's going to be the key. If you're going to make hydrogen, make it local. There's no reason to ship the stuff, or maybe to ship it through pipes. Man, that's a big discussion point. But Rosemary, am I off here? It just seems like hydrogen's so easy to make. If you're going to make it, just do it where you are. Don't put it on a ship. That's just going the wrong way.
It is really interesting, because if you look at, there's a lot of countries around the world have hydrogen strategies, and very many of them rely on either exporting or importing hydrogen over a long distance. So Japan, Korea, and Germany would be the main ones that people are talking about. And we actually, right now, the world's very first liquid hydrogen ship is in a port in Victoria in Australia. So there's this project, it's called HESC. I can't remember what that stands for. Hydrogen export, I guess, is the H and E. And it's a joint partnership between Australia and Japan. And this particular project has gotten a lot of attention because it's incredibly dirty. And if I describe the steps to you, it just sounds so silly compared to just shipping coal and burning that. But so there's they're taking brown coal in Victoria, and then they gasify it to make hydrogen, and there's a lot of emissions associated with that, and those emissions are just going into the atmosphere. And then they put the hydrogen onto trucks and they drive it, I think it's like 400 Ks to the port, where they liquefy it, and you lose a third of the energy in the hydrogen to liquefy it. They put it on the ship, which is, it's been modified from an LNG ship, but obviously the two gases or liquefied gases are very different, and hydrogen with its tiny molecules and very low boiling point.
Right.
People expect there to be a lot of losses from boil off and also from just leakage. So then it's going to travel on this liquid hydrogen ship 8,000 kilometers to Japan, where they're going to do, whatever they want to do with it, either put it in a power station or fuel cars. And so, overall the emissions are much higher than if we just shipped Japan coal and they burned that. They've bought offsets for the project to, and a lot of people are calling it blue hydrogen, which I think is a real stretch to call it blue hydrogen when they're just buying offsets. They eventually plan to capture the carbon and store it, but they've been trying to find a suitable location for a long time now and still haven't. So,
can you reiterate real quick what the difference between blue and green are?
Oh, yeah. So blue, normal hydrogen, 99% of hydrogen today is made from natural gas or coal, mostly gas, and the emissions just go into the atmosphere. So, it makes a lot of emissions, and a lot more compared to if you just, burned coal or another fossil fuel. Then there's blue hydrogen. It's the same thing, but they capture the emissions and store it. or use it. And then there's green hydrogen, which is made from using renewable electricity to electrolyze water and split the H2O into hydrogen and oxygen.
Okay, got it.
Yeah, so there's a lot of debate about which of these are clean hydrogen and what you can call blue, but I never heard anyone call something blue hydrogen where there was no carbon capture and they just bought offsets from somewhere. So that's been a lot of the focus of the discussion about this project is about it's incredibly dirty and the dumbest way to make electricity in Japan, to export energy from Australia to Japan. It's dumb economically, it's dumb for the environment. But I actually think it's a really great project because finally someone's going to put hydrogen on a ship and transport it, because all these countries have so much volume of hydrogen that they're expecting to be exporting long distances between countries that have too much energy, renewable energy, and countries that have not enough. Finally, we'll be trying it out. We'll see. Everyone talks about the cost and the losses, inefficiencies. We'll be able to actually see what are these, how much hydrogen is left at the other end once that ship, gets 8,000 kilometers away. So, yeah, I'm interested to see how this project works out, even though on the face of it, it's such a horrible, dirty project. At least it's, we're doing something. Finally, we've stopped just talking about exporting hydrogen and we're actually going to do it. And I suspect we'll find out this is a stupid way to transport hydrogen and that it would make more sense to convert it to ammonia, or maybe it'll be just too expensive to export a lot of hydrogen and everyone will make it for themselves. I don't know yet, but at least it's a step on the road to finding out what the most sensible solution is.
And so sticking with hydrogen, there's a new report from Wood Mackenzie. Obviously, they do a lot of consulting and analysis and forecasting. And one of their analysts is claiming that green hydrogen should be able to be produced for $1 a kilogram in some countries by 2030. Alan, does that seem realistic to you?
It could be. I did look at the breakdown of what the consumer cost is for hydrogen, and where are the costs in the manufacturing, in the handling, in the shipping. I mean, what is it? What do you pay? What are you paying for at the end? And it's surprising how much is in shipping. Like you could make it for $1, but it's still going to cost you X amount of dollars to get it shipped, and it's a lot more than the cost of the hydrogen itself. In fact, it was like the consumer cost is like, oh man, I forget the units here, but it's like $12. Let's say it's $12, and $1 was made to the hydrogen. Well, there's another $11 in the middle, which is just the transport and handling of the hydrogen. And so you can make hydrogen free. It's still not going to really lower the price enough to make it economical. And I think that was the real kicker, was just sort of the energy density of the material and the cost to transport it. It doesn't make sense. And if we're following the money here, there isn't any money. And so you gotta kind of pick where your battles are here, right? If you look at the distribution of where all your costs are, you try to hit the big ones first and leave the little ones alone. They're attacking one of the littlest costs in the total cost structure, which was odd. So when I think as a general consumer, you think, oh, this is great, right? And I think this is part of why these articles are written, is because the consumer picks it up and goes, oh, that's really awesome. And then some economist says, or business person sits down and says, yeah, but it's still $11 to get it to you. So it doesn't matter. And I think that's where when, Rosemary and I have been doing engineering probably way too long, actually. So when you get down to the nuts and bolts of it, you're like, engineers just go, no. And I think we're a little dismissive at times, but we're dismissive because we try to gauge what the real costs are from inception to final product. And if you can't make the money or can't build it in the time you need to, then it's not worth doing. And I'm totally okay. I think Rosemary is too, right? We're okay on trying stuff. Like, awesome, right? Let's try it. And there's no reason we shouldn't make the world a better place. Everybody should be trying to make the world a slightly better place. The question is it the right time for that, right? A lot of engineering is not so much, is it this device cool or is it not great tech? It's a combination of great tech, great cost structure, proper timing. And we're missing one or two of those in this hydrogen equation at the moment. And Rosemary, you see, like there's just, if we're all just sitting around and having lunch together, there's 100 engineers. How many are saying this hydrogen thing's going to work out in the end? 1? 2?
Oh, from engineers, yeah, not so many.
Yeah.
Yeah, but I think engineers can be too dismissive sometimes. And I think with the hydrogen debate, with the hydrogen debate, there's also something I think a lot of engineers miss, which is just because it's not the technically best solution doesn't mean that it's not the one that's going to happen. There's really a lot of political will to make it happen. And just your average environmentally conscious person on the street really thinks that hydrogen is the solution that we need. So I see a lot of pressure. So I think we'll see more hydrogen than you would get if you just got engineers to design the system and everybody else just did what they said.
Sure.
Which maybe that wouldn't. Engineers often miss important things like social factors and that sort of thing. So
okay, I'll give you that. Yes.
So I do think it's good that engineers don't just run the whole show without any input from anyone else. But I think a lot of engineers are going to be surprised at how much hydrogen we see, even though in some cases it's not feasible. So I think that there are some use cases that are just so ridiculously inefficient that it is just not going to happen. Like in Australia, blending hydrogen into natural gas pipelines to continue heating homes in that way doesn't make sense. Maybe there's more of a case for it in Northern Europe, but there's definitely not in Australia. Passenger cars, just no way, just never going to happen. You would have to really, really subsidize a lot. But then I think there's a lot of in-between cases where, maybe hydrogen can be made to work as well as something else. And with a little bit of, subsidy, a little bit of a few government programs to, grow the industry ahead of, the market, I think you could see some. But what I did think was really interesting about this report was, I assume that they've got their set of assumptions and say this is a plausible scenario where you end up with $1 a kilo hydrogen, which would be very cheap. They did it with cost of electricity needs to cost $10 a megawatt hour or lower, which I think is definitely plausible in the future for places that, have a lot of really great solar and wind co-located. Yeah. Definitely achievable. And then the other point was with the capacity factor of 50%. So the electrolyzers are running on average half the time. So again, that's, either a really good wind farm on its own could reach 50% capacity factor. A solar farm probably never can because, it's night half the time. But solar and wind together could reach that. But one thing that you can't do with if you need a 50% capacity factor, you can't just turn it on when the prices go negative on an electricity grid. That's never going to be 50% of the time. So I think that super cheap hydrogen isn't going to happen in combination with using hydrogen to balance a variable renewable electricity grid, which is something politicians especially, have been talking about since the very start of, the buzz about the hydrogen economy, and has always seemed to me that the most unrealistic part of the idea that you would ever be able to make really cheap hydrogen by buying an expensive electrolyzer. Even if they get cheaper, you buy a piece of equipment and then run it, 10% of the time to, match your variable renewables. That I think this report shows that that's not something that's going to happen.
So are you as concerned about the price target, or are you just more concerned with just swapping out gray hydrogen for green?
Yeah, I think that's definitely the first thing that we need to do, because currently hydrogen is an emissions problem rather than an emissions solution. It's an incredibly high emissions industry if you add up the whole world's use of it. And the interesting thing about the report is it's saying that green hydrogen could end up under $1 a kilogram. That compares to the current cost of grey hydrogen, so that made from fossil fuels with no carbon capture. That's around $1.70 a kilo in 2019, and likely much higher now that the natural gas that they're making the hydrogen from is more expensive. So I think that's really important that green hydrogen needs to get cheaper than grey. Otherwise, we're going to have problems with cheating, I think, like as we rush to massively expand the hydrogen economy, there's this real risk that we end up increasing emissions, because if we can't keep up or we can't make the projects economic with green hydrogen, then people are going to be substituting in grey, or there's going to be the risk that happens, even just as a stopgap. And, it's because it's so inefficient to convert from gas to hydrogen back to electricity compared to just burning the gas and getting electricity in the first place. So you end up with more emissions by going through hydrogen. So to me, there is a risk with the hydrogen transition that we end up in the short term with a much, more emissions intensive outcome. And I think the fact that green hydrogen is predicted to come down in cost to below that of grey is really promising that is maybe not so likely to happen.
Well, let's transition here to our final topic for today, which is one of Rosemary's favorite animals, which is the common bird, and some technology to help protect them. Obviously, this is a big cause of contention. This is one of our former President Donald Trump's big claims that, they just kill tons and tons of birds. Obviously, they do kill a certain amount of birds, which we've discussed at length in different shows. But there's a tool from a company called Intelliflight, and it's won some awards over in Australia for its performance. In 2018, it was installed in a Tasmanian facility and was found to cut eagle deaths, the Cattle Hill wind farm, down by more than 80%. So, Rosemary, obviously birds are a big concern. We want to keep them alive, minimize their risk as much as we can. But I guess my question to you first is, what's going to incentivize companies to buy this? If you already have a wind farm that's operating, activists or protesters aren't beating down your doors, are you going to spend the money to put something like this on your wind farm? And what's going to force people to do this?
I don't think that they will put them on a wind farm if there's not a lot of bird deaths there, and they're not, if there's not a problem that conservationists are upset about, or if they're not breaking the rules of their development. I think that this is going to happen in places where birds are a problem for getting approvals or for continued social license to operate. So the wind farm in Tasmania, where this system was trialled, it is in an area that is home to, I think it's a little wedge-tailed eagle. So the one we have on the mainland, a wedge-tailed eagle, it's one of our best Australian birds. It's a humongous bird. It's like 2.3 meter wingspan, really, really big. And they're not endangered, but it has a little cousin in Tasmania. They're a bit smaller, and they're an endangered bird, and they were being affected by this wind farm. And so if the wind farm wants to continue to operate, then they need to find a solution to that. And so they have, effectively here done that, and now they're going to translate it to other wind farms that have problems with birds. I know we've talked about some on the podcast in some of those, was it a Great Lakes development, that people are very concerned about the potential impact on birds. And I would see this as an easy way that you can get around it, saying, we're going to monitor and we can install this system if it turns out that birds are being killed. Our assessment says that we don't think that they will be. If we're wrong, then we'll install this system and we'll turn off the wind turbines anytime there's a bird around. And I just think that just having that technology available in your back pocket should make it a lot easier to, reassure everybody that you're on the side of the birds and you're gonna do what it takes to keep them safe.
I just watched a presentation by Energy Systems based up in Vermont, not very far from here. They were looking at bat deterrent systems, and they were tracking the flights of bats. I thought, my gosh, like radar tracking the flights of bats, that's pretty cool. And if we can do that, I think the next stage is not so much to turn off the turbine. I think the next stage is to have some way of discouraging the birds, the bats, whatever, to fly around these areas. I think that's ultimately where it's headed. I don't know if we talked about this in the podcast. Maybe we did a couple of, probably 10 episodes ago now, where painting one of the blades like half black, half white seemed to make a big difference in bird deaths. Like it reduced them like 60%, some crazy number, right? So and you got to wonder, the technology is only going to get better, right? As we learn more about what would discourage birds from flying into wind turbine blades, and it seems like that's the issue, like the birds actually have to physically contact the blades. If we can reduce that in any measure, and just monitoring where they're at is such a huge step, because now we understand what's going on and why are they there. Maybe there's a reason why they are there. Maybe there's insects or some sort of rodent on the ground around there we could move. I think the technology just lends itself to sort of more study, and until we have those tools in place, we can't do the things we're going to need to go do. So these are just early steps. I just find it fascinating that the technology is catching up so fast that we can monitor the flight of birds very accurately, and bats and other things. It's just incredible.
Yeah, and this one's more actually more optical based than radar. So it has a couple high-res stereoscopic cameras, and it has 8 wide field of view cameras as well. So it looks like it's using more optical than radar. But you're right; it seems like it's complicated. Seems like it works pretty well. But yeah, it's a good question about if there should be a hybrid solution. Like you said, should you paint the tips black, and is that going to get you closer from the 80% reduction to upwards of 90%? Like what kind of hybrid system could maybe companies use to not just choose one solution but get the best of all of them?
It's a good question, and I don't know if everybody saw this, but there's been some recent video of the latest full self-driving by Tesla. And if you watch
which is not even close to full self-driving, by the way.
Okay. Yeah. All right. So it's a misnomer. I'll grant you that. But if you watch how that system works, and that's a vision-based system too, right? How fast it tracks humans and non-humans, and where stop signs and speed limits and bicyclists and the whole thing. The ability to sense, detect, and accurately project what those objects are is mind-boggling how well that happens. And that technology will eventually flow down. It'll take years. I mean, it'll probably take a decade, right? But the next thing we'll be doing things on wind turbine blades we'll see that bird come, and we'll make an adjustment to the wind turbine, kind of shoo it away. Maybe make the wind turbine make more noise, right? Change the pitch of the blade, make it a little more noisy, just for that brief instance to turn the bird away. Those are things that are possible with a little more technology. We're just going to we got to give it a little bit of time to flesh itself out, but that's the future, man.
Yeah. And of course, a lot of this technology is in use. I mean, tennis, they had the Hawkeye system. That was their optical in or out system. That has since been adopted by Major League Baseball. They were using a radar-based, the TrackMan system. They're now going to the Hawkeye system, which essentially tracks every player's movement on the field in real time.
It's crazy
throughout everything. So it seems like these are similar technologies. And it seems like, given a choice, more companies are maybe choosing optical versus like radar sensors. When I don't know the specific applications, and I don't know if that the tracking systems that would work in tennis or baseball would work in something like this, where you have to track pretty far out in front, right? Maybe multiple hundreds of yards. So you'd be interested to see how some of these are overlapping, and where you see technology being borrowed or adapted from different sectors where it's already in use.
Matter of time. That's all it is. It's a matter of time.
All right. Well, that's going to do it for this week's episode of the Uptime Wind Energy Podcast. Thanks so much for listening. Wherever you are on the web, on Spotify, YouTube, iTunes, Stitcher, definitely leave us a review, share the show with a friend, and be sure to subscribe to Rosemary's YouTube channel, which you'll find in the show notes below, and to our weekly podcast and news update called Uptime Tech News, which again, you'll find in the show notes of this podcast. So thanks again for listening, and we'll see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. This is why it just makes sense to install a WeatherGuard Strike Tape LPS upgrade the next time your technicians are going up tower. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.